Pavel from Carbonterra, and we're coming to you from the Crop Production Show in Saskatoon. Today we've assembled a panel of experts here for you, and they're going to be discussing fertilizer, all these proposals that the government has been making on the reductions of emissions, and as well as how you can improve your nitrogen application efficiency in the field without impacting your top line. So now that, of course, we know all you farmers out there, you're the ones actually feeding the world, and we need to ensure that you actually have the fertilizer that you need to run your operations. But with that being said, there's always room to improve your nitrogen application efficiency, and at the end of the day, you can of course keep your yields high and continue to reduce the amount of nitrogen you actually need to purchase. So let's start us off by introducing our panel. First, we have Dr. Eric Micheels here, all the way on the right. He is an associate professor at the University of Saskatchewan who teaches agriculture economics and agribusiness management. His research focuses on the drivers of performance on farms and agribusiness, and his current projects focus on the adoption of agriculture innovations and the use of alternative marketing strategies in the search for increased profits. Next, we have Brian Rumberg. For the past 12 years, he's been working in sales and people management in the agriculture industry. He's currently running the entire AgraCity sales team, so he has a vast knowledge of crop inputs. He previously ran his own soil sampling company, where he was able to help numerous farmers make fertilization decisions. Finally, we have Jason Mann. He's the president and CEO of Genesis Fertilizers. He has extensive experience in operations, project startups, and agribusiness management on a domestic and international level. And he's, of course, he has very in-depth knowledge of fertilizer markets. So let's go ahead and kick this off with the first question and get some clarity around what the federal government is actually proposing with these voluntary reductions and exactly how they see the farmers implementing this. So why don't you start it off, Dr. Micheels?
Yeah, thanks. So the long and the short of it is basically the federal government would like a 30% reduction in fertilizer emission by 2030. So that was a 30% reduction from, I think they want the 2022 level. I haven't seen that number, but the most recent number of fertilizer emission I saw was around 12 to 13 million or megatons of CO2 equivalent. So they would like a 30% reduction of that by 2030. That's somewhat in line with what other jurisdictions are trying to do in terms of working towards being more climate resilient. I think the EU is proposing a 20% reduction. Other jurisdictions may be proposing something else. This is moving towards that 2050 target that a lot of jurisdictions are looking at to be net zero, whether that is attainable or not, but this is kind of a step in that direction. Again, this is a 30% reduction in emissions and not a 30% reduction in intensity, right? So they want that 30% reduction in what is emitted, not necessarily bringing into account if production goes up and fertilizer use goes up as a result, or because of that, it's that 30%. They want that. The initial thought, and what everything I've read so far has been the 30% reduction in that 12 to 13 megaton equivalent from that, and not accounting for that intensity that would bring in production.
That makes sense. And I think farmers are probably still going to be somewhat concerned about having to reduce emissions in general. So how would you propose they might be able to do this?
Oh, for sure. I think what has been proposed is a lot of what is currently available, and it's not necessarily new technology that the government is suggesting might be a pathway to that 30% reduction. You know, they're talking about crop rotation, more pulses in the rotation that could help the farmer, use some of that nitrogen that is fixed in the soil. They're talking about 4R stewardship, which is adopted. It's already prevalent and maybe not as widely adopted as we would like, but there is certainly adoption of that. Farmers are still, fertilizer is a huge expense for these farm businesses, so they're not in the business of applying this without any thought or thinking about how putting the right amount of fertilizer at the right time, because they want to get that return on that investment. They don't want that expensive input to leach away. That's not their goal. So what's proposed by the government, or what the government is hoping, is that some of these technologies to get to that 30% reduction are already available, and maybe they just work to increase that adoption. So they're looking at rotation, they're looking at 4R, they're looking at other pathways like that.
Mm-hmm. Yeah, that absolutely makes sense. And Brian, of course, you have the agronomy experience here on the panel. What's your thought on this 30% emission reduction, and do you think farmers are actually able to achieve this?
I mean, I think the Canadian farmer is already doing a really good job in minimizing emissions relative to, lots of farming around the world. I do believe there is absolutely opportunity to reduce our emissions. As stated, it's not about using less, it's about using what we're already applying and make sure we minimize the emissions. So stuff like nitrogen stabilizers, greater adoption of VR, putting fertilizer in the right place. There are lots of new technology emerging in fertilizer itself, which is great, because there was probably a 40-year period where there was virtually no new technology in fertilizer. Just maximizing yield, making sure that our crops, we do the other things right to maximize yield and have the crops consume the nitrogen that's in the ground instead of it gassing off and creating a problem. So I do believe it is possible for sure.
Awesome, great to hear. And Jason, of course, you're the CEO of Genesis, and you guys are dealing with all the fertilization side of things. So how do you see Genesis playing into this and actually helping with these reductions?
Great. Well, first I'd start off with saying when the government came out and announced this 30% reduction, there was a lot of misunderstanding. And everyone thought this was an absolute where nitrogen had to be reduced by 30%. And I don't think that's the case. And Fertilizer Canada has done a great job responding to that, in that, really what we should be looking at is, instead of saying, we just got to reduce the amount of nitrogen used on your farm, which I don't think is the right approach. It's using it more efficiently, and it all goes back to 2020 is the baseline. So it's what happened in what the numbers were in 2020 is what they want to reduce that by 30%. Emissions, not necessarily the amount of nitrogen used. So again, it's about reducing the emissions on that nitrogen. And there's lots of tools in the toolbox to do this, and the government has come up with some programs to help farmers change their farming practices. But the reality is, it comes at a cost, because as you start reading into the plan or the proposals from the federal government, talking about, 4R stewardship, which is great and should be done, but it's your environmental planning. It's your variable rate mapping. It's using these inhibitors or stabilizers on your nitrogen. There's a whole toolbox of things, but they all come at a cost. So a concern I have as being an advocate for the farmer is, you have all these people lining up to capture the rents of these programs. So now does the farmer have to pay for an environmental plan? Do they have to pay for variable rate mapping? They have to pay for the fertilizer treatments. And if you just do some simple math, typically a treated urea product, where you're going to add some type of stabilizer or urease inhibitor, it can run up to about $150 a ton. Now, if there's 3 million tons of urea used in Western Canada a year, that's $450 million. That's a lot of money for the farmer to absorb. And yet the farmer's tasked with the job of, they've still got to have their top line. They've got to grow, food for the growing population, and they have all the other risks that come with running their business, whether it's weather and it's increasing costs and labor issues and all kinds of things. So, who's going to pay for that? So this is a concern we have at Genesis, and why we're trying to get farmers involved in the fertilizer value chain. To be able to capture those rents, whether it's the profits on the fertilizer production itself, or the profits on these treatments. For example, if that treatment costs $150 a ton, farmers aren't adopting it because of the cost. But if they're participating in the profitability of that product and getting dividends back, now maybe that's only going to cost them $50 a ton, and you're going to get much greater adoption. So there needs to be some mechanisms in there to allow farmers to use all these tools, and that's what we're trying to do at Genesis, to get farmers involved in the value chain and participate in some of this. And I think part of our goal is to make sure that every ton leaving our proposed facility is meeting these challenges, whether that's treated product or other specialty products that can be attached to the blends.
Well said. So, of course, these added coatings, the inhibitors, they all do add cost. And I'm curious, Brian, from your standpoint in agronomy, and you work with a variety of different farmers, different farm sizes. How do you see the cost benefit playing out for the average farmer who's adopting these sort of tools?
So I think there's been, or I know there's been more and more research that is showing that despite the Canadian farmer probably using fertilizer the most efficiently of any farm in the world virtually, we are still subject to losses as much as 25% of our urea, even when we do a soil banded situation, which is pretty common across Canada. So, when you look at the cost of, treating fertilizer, yep, there's product, $150 a ton. You can probably get it done for, maybe in the neighborhood of $70 a ton. If you look at minimizing that 25% as a worst case scenario and take that down to a very negligible amount, the cost of the treatment becomes, actually an investment and a positive ROI situation. When we're looking at $1,000 a ton urea today, that's virtually $1 a pound. So, if you take an average, you take a farm who applies 200 pounds of urea, if you're saying 25% is being lost as a worst case, that you're talking about losing as much as $20-25 an acre just to nitrogen losses. So all of a sudden, a $7 an acre, $6 an acre investment, that sounds like a pretty good investment. There's also lots of research that these nitrogen stabilizers, because they're reducing nitrogen losses, are having a very positive impact on yield. I was looking yesterday at some research that had been done, and they were showing 5 to 6 bushel an acre increase in canola yields by the addition of an NBPT treatment on urea. At $20 a bushel, that's a pretty good investment. So I think a lot of farmers, I started in the retail channel in early 2000s, and at that point in time, it was all about how do you cut every cost out of production possible. I think things have dramatically changed over the past 20 years, and now there's a lot of guys looking at, not so much about how do we cut costs, but how do we maximize our ROI, and there is a lot more, potential farm profitability at the farm gate.
It's really great to hear. And looping back to GHG emissions as a whole, Jason, with Genesis Fertilizers, what other things are you actually doing to help reduce GHG emissions?
Right. So as we do the engineering and design work on the proposed new facility, we're looking at what new technologies are out there, because this is a new plant, and if you look at any of the other plants in Canada, the newest one was built in the early 90s, so it hasn't been a new plant in 40 years, I think. So obviously there has been some change in technology. There's a lot of talk about green ammonia, blue ammonia. Certainly we would be building the most efficient plant where we would have the most minimal carbon footprint we can have, but at the same time outputting products that are designed to mitigate the amount of nitrous oxide emissions or gassing off. So that's a big goal of the project. And as we get through the front-end engineering and design work, we will be looking at all those different technologies and what products we can incorporate into the production process to meet these challenges.
Excellent, good to hear. And what does the timeline actually look like right now for Genesis?
Right now we are doing a capital raise with Western Canadian farmers, well actually all Canadian farmers, and we are starting the front-end engineering and design work in Q2 of 2023. So it takes about a year to do all the engineering work, and then if everything lines up and the costs and like meet what we think it's going to be, and if the feasibility is there, then we would put a shovel in the ground in about second half of 2024. And it takes about 32 months to build the plant.
Excellent. Very exciting. So let's go ahead and wrap up the discussion, and I'll let Dr. Micheels take it away and give us any of your final thoughts.
Yeah, I think one thing to think about or to maybe help convince the government on is maybe to move not towards just that hard reduction on that emission, but maybe move towards that intensity. How much fertilizer is emitted per ton of production. That might be a more reasonable goal that aligns with all of the goals that the government has kind of put on farmers. They want, as Jason said, farmers are supposed to, grow food for a growing world population. They're supposed to, contribute to their own communities. They're supposed to, at the same time, reduce fertilizer emissions. So can we do that in a way, or can we structure that in a way that those goals align? So if we can think about fertilizer emission as a per unit of production, that might be a goal that everybody can kind of get on side with. And then there's still room for improvement there. And I think that brings all aspects of agronomy together. So in terms of plant breeding and how we can develop new varieties to utilize nitrogen more effectively, more resilient to the weather shocks that we've been seeing in Western Canada. So if we can ensure that production actually gets harvested, we're gonna actually reduce that or increase that intensity, and create those wins throughout that supply chain. So I think there's ways to achieve that goal that the government is set out, but also make that more aligned with what the farmer is trying to do in terms of their own top line and bottom line as they move forward.
Absolutely, great to hear. Yeah, the last thing we'd want the farmers to do is reduce their yields.
Yeah.
So, absolutely great to hear. So, Brian, what are your final thoughts here?
You know what? I think, I guess I'm grateful that I'm involved in this industry, and it was by fluke. I was looking to go into university in '89, and I think the guys on the panel here, we all know that agriculture wasn't very sexy in that timeline. And just as it happened, I ended up in agriculture, and I look at all the advancements and everything that has happened in the past, 30 some odd years, and where the farmers are today, as far as the technology. I mean, amazing machines out there. They look a lot different than the stuff that I grew up driving as a kid, and we've talked about it. As it's amazing how far everything has went. And I do think these new goals, when they first came out, I would have been one that would have been part of the group laughing, saying, did we really think about this? But after further understanding that we are talking about emissions, and if you look at all the tools available, to maximize yield, new varieties, new technology, new application technology, the days of 3417 fertilizer are long gone. Lots of new fertilizer products as well that are, high efficiency. I believe it is possible, and I believe it's going to be actually in the farmer's best interest to, explore and look at, all this new stuff that is coming forward, and will actually make them more profitable at the end of it. So, I think there's lots of positives. I think we can, be better stewards of, planet Earth, and, be more profitable. So I think it's, there's lots of good news, that's for sure.
Perfect. Win-win situation.
Yep.
And Jason, final thoughts?
Well, I just think that, excuse me, whatever the federal government is doing, they really need to really listen to the farmer, and the farmer is a stakeholder here. They are the stewards and the operators of the land, so they have to have buy-in to what's being done here. So whatever is being, coming out as final policy needs to you know, have the uptake of the farmers. You just can't have a stick there and say, you gotta do this, you have to do this. It has to make economic sense, and if it does make economic sense, farmers will do it. Farmers are very savvy, and they you know, they do look to maximize their profitability and manage their costs and their inputs. So, you know, I think it's also achievable. I think 30% is a big number. I'm probably more in line with Fertilizer Canada's assessment of more around 14 to 15%. But if we can do better, that's great. So, but the bottom line is something does need to be done there to you know, reduce these emissions. And as I say, farmers are great stewards of the land. It's just like they are, you know, sequestering a lot of carbon in the soil, and that also needs to be recognized. And that's, you know, part of this larger discussion around agriculture, land stewardship. So, looking forward to dialogue with all the stakeholders to land on a final plan.
Perfect. Great way to wrap this up. So thanks a lot, gentlemen. I think I learned a lot today. I know our audience probably did as well. Really appreciate all your insights, and I'm excitedly looking to follow Genesis and see how the project moves on. Well, thank you very much.
Thank you.